Hello everyone, good evening. Today I'm going to talk about the project Image to Sentence Generation. As the name implies, it's a process of generating textual description for an image, and it makes use of both NLP and computer vision for generating the description of an image. And the dataset being chosen is the Flickr dataset, and the technology that's being adopted is the CNN and LSTM for this project, two deep learning models. So the as we know, the CNN basically used for extracting the features from an image, and then the LSTM for the sequential data. And the benefits of this use case is having more uh, understanding of an images from a surveillance cameras and improving the navigation assistance for the impaired individuals by taking the photos around their surroundings and get to know what is there around their surroundings. And then it's more organizing and categorizing the large image data sets by the search feature. Yeah, this is the problem statement, right? Like when you get a large number of images, like you don't know what to do those with the images, like what each image is being referring to, right? So we can use this in term for grouping and categorizing the images, searching of the images by the query, and then helping the navigation for the impaired individuals by becoming more awareness around their surroundings. So the solution being implemented follows this architecture. So you got a sequence of words, and that's they use you apply some embeddings and passing into the LSTM layer, and then you got an image and extracting the features using the CNN models, and the output of both of these are fed forward or forwarded to the feed forward network, having a dense layer and having a softmax as an activation function, which outputs the uh, probability of the word as like the for all the words of our vocabulary in size. That way we can get to know the sequence of words as an output. So this is the how the dataset looks like. You got an image and then the caption for that image. So there are 8K images and 5 caption for each image, so around 40K captions. And for the text we do a text pre-processing, and then from an image we extract the feature using the transfer learning. So we are not building the model, instead we are making use of the model that has been trained on the large ImageNet data set. So we use that model for the feature extraction. So this is the model building code. So you get to see like uh, the inputs, like for the partial caption the sequence model, for the sequential data the LSTM, and then for the image it's a CNN the ResNet model, and then for the like it being fed into feed forward network, like having a dense layer with an activation function, softmax, and then we'll get to predict that word. This is the model, and if you look at the loss after the fifth epoch, the validation loss tends to increase because of the training being done on the data gets overfitted. So because of overfitting of the data, so the validation loss after the fifth epoch tend to increase. And from an inference perspective, this is how the prediction looks like. So the child is jumping over the playground. Ideally the predictions could have been better. So instead of the child is jumping over the playground, it could have been like child is playing on the branch of the tree. So thank you very much.